Techniques for electrical installations in log homes. Firstly, log notches. Notches must be cut into the logs to accommodate electrical wiring or conduit. Use a chainsaw or router to create notches that are deep enough but not so deep as to weaken the logs. Secondly, drilling holes. Drill pilot holes before driving screws or nails into logs. Use a sharp drill bit and apply pressure evenly to prevent splitting. Avoid drilling too close to the edges of logs. Thirdly, conduit and wiring. Use metal conduit to protect wiring from moisture and insects. Secure conduit with conduit clamps or straps. Pull wires through conduit carefully to avoid damaging them. Fourthly, electrical boxes. Use metal electrical boxes that are rated for outdoor use. Secure boxes to the logs with screws or toggles. Ensure that boxes are level and flush with the log surface. Fifthly, panel location. Choose a central location for the electrical panel to minimize wire runs. Mount the panel on a fire-rated wall or on the exterior of the home. Sixthly, wiring methods. Use non-metallic sheath cable or metal-clad cable for wiring. Avoid running wires perpendicular to logs to reduce the risk of damage. Seventhly, grounding. Install a grounding rod and connect it to the electrical service entrance panel. Use copper wire and ground clamps to connect the grounding rod to the electrical system. In addition to these techniques, consider the following tips for electrical installations in log homes. Inspect the logs, check for any cracks, rot, or damage before installing electrical components. Use weatherproof materials. All materials used should be resistant to moisture and ultraviolet rays. Plan ahead. Determine the locations of outlets, switches, and fixtures before starting installation. When working with electrical systems in log homes, it's crucial to adhere to the National Electrical Code, or NEC, and local building codes to ensure safety and compliance. Log homes present unique challenges compared to standard residential construction, primarily due to the natural settling and movement of the log. This settling can impact wiring and connections, potentially leading to safety hazards if not properly addressed during installation. Notching the logs is a common method for concealing wiring and conduit, but it's essential to ensure that the notches do not compromise the structural integrity of the logs. Use a chainsaw or router with precision to create appropriately sized notches, and consult with a structural engineer if there are any concerns about weakening the logs. Drilling holes for running wires or securing electrical boxes should be done with care to prevent splitting the logs. Always use sharp drill bits and apply even pressure. Avoid drilling too close to the edges of the logs, as this is where they are more susceptible to splitting. Pre-drilling pilot holes before driving screws or nails can also help prevent splitting. Conduit is highly recommended in log homes to protect wiring from moisture, insects, and physical damage. Metal conduit, such as electrical metallic tubing, or IMT, or rigid metal conduit, or RMC, provides excellent protection. Secure the conduit to the logs using conduit clamps or straps, ensuring that the installation is neat and professional. When pulling wires through conduit, use wire lubricant to reduce friction and prevent damage to the insulation. Electrical boxes should be metal and rated for outdoor use, as log homes often have more exposure to the elements than standard homes. Secure the boxes to the logs with screws or toggles, ensuring that they are level and flush with the log surface. Pay close attention to sealing the boxes to prevent moisture intrusion. The electrical panel should be located in a central location to minimize wire runs. Mount the panel on a fire-rated wall or on the exterior of the home. Ensure that the panel is easily accessible for maintenance and repairs. When choosing wiring methods, non-metallic sheath cable or NM cable and metal-clad cable or NC cable are commonly used. However, avoid running wires perpendicular to logs, as this can increase the risk of damage due to settling. Instead, run wires parallel to the logs whenever possible. Grounding is essential for safety in any electrical system. Install a grounding rod and connect it to the electrical service entrance panel. Use copper wire and ground clamps to connect the grounding rod to the electrical system. Ensure that all metal components, such as conduit and electrical boxes, are properly grounded. Furthermore, before starting any electrical work, thoroughly inspect the logs for any cracks, rot, or damage. Address any issues before proceeding with the installation. Use weatherproof materials for all electrical components, as log homes are often exposed to moisture and ultraviolet rays. Plan the locations of outlets, switches, and fixtures carefully before starting the installation. This will help to minimize wire runs and ensure that the electrical system meets the needs of the occupants. Understanding key NEC articles is critical for safe and compliant electrical installations. Article 210.8 covers ground fault circuit interrupter, or GFCI, protection for personnel. In log homes, GFCI protection is required for all 125 volt, 15 amp and 20 amp receptacles in bathrooms, kitchens, garages, and outdoors. GFCI protection is also required for receptacles within 6 feet of sinks, tubs, and showers. Article 250 addresses grounding and bonding. Proper grounding and bonding are essential for safety and to prevent electrical shock hazards. Ensure that the grounding electrode system is properly installed and connected to the electrical service. All metal components, such as conduit and electrical boxes, must be properly bonded to the grounding system. Article 300.4 covers protection against physical damage. Wiring installed in log homes must be protected from physical damage. This can be achieved by using conduit, raceways, or other approved methods. Avoid running wires in areas where they are likely to be damaged by settling or movement of the logs. Article 310.15 covers ampacity of conductors. The ampacity of conductors must be sufficient for the load they will carry. Consult the NEC tables to determine the appropriate conductor size for each circuit. Consider the ambient temperature when selecting conductors, as higher temperatures can reduce ampacity. Article 314 covers outlet boxes, conduit bodies, and fittings. Outlet boxes and conduit bodies must be properly sized and installed. Ensure that the boxes are securely mounted to the logs and that all connections are made properly. Use weatherproof boxes and fittings in areas exposed to moisture. Article 334 covers non-metallic sheath cable, or NM cable. NM cable is commonly used for wiring in log homes. However, it must be protective from physical damage. Avoid running NM cable in areas where it is likely to be damaged by settling or movement of the logs. Article 340 covers metal cloud cable, or MC cable. MC cable provides better protection than NM cable and is often used in areas where physical damage is a concern. MC cable must be properly grounded and bonded. Article 406 covers receptacles, cord connectors, and attachment plugs. Receptacles must be properly installed and grounded. Use tamper-resistant receptacles in areas where children are present. Weather-resistant receptacles are required in outdoor locations. Additionally, consider surge protection. Log homes, especially those in rural areas, may be more susceptible to power surges. Install a surge protective device, or SPD, at the electrical service entrance to protect electronic equipment from damage. Consider energy efficiency. Use energy-efficient lighting and appliances to reduce energy consumption. Install dimmers to control lighting levels and save energy. Seal any gaps or cracks in the logs to prevent air leakage and improve energy efficiency. Think about future expansion. Plan for future electrical needs when designing the electrical system. Install extra conduit or wiring to accommodate future additions or modifications. Consider the use of smart home technology. Smart home devices can provide added convenience and energy savings. Install smart switches, thermostats, and other devices to control lighting, heating, and cooling. Finally, document the electrical system. Keep a record of all electrical work, including wiring diagrams, panel schedules, and inspection reports. This documentation will be helpful for future maintenance and repairs. Always consult with a licensed electrician who specializes in log home installations if you have any doubts or require additional guidance. Log homes present unique challenges that require specialized knowledge and experience. A qualified electrician can ensure that the electrical system is safe, code compliant, and meets the needs of the occupants. Safety is paramount when working with electricity. Always to energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The electrical systems typically found in log homes closely resemble those in standard residential houses, operating on a 120/240 volt, single-phase, 3-wire system. This setup allows for both 120 volts for lighting and small appliances and 240 volts for larger appliances like electric ranges, water heaters, and air conditioners. The service entrance, usually located where power lines enter the house, contains the main disconnect, meters measuring power consumption, and connections to the grounding system. The electrical panel, often referred to as the breaker box, divides the power into different circuits, each protected by a circuit breaker. These circuits deliver power to receptacles, lighting, and appliances throughout the house. Wiring is typically concealed within the walls or run through conduit for protection. Grounding is critical to ensure safety by providing a path for stray electrical currents to return to the source, reducing the risk of electric shock. The grounding system typically includes a grounding electrode, such as a ground rod or water pipe, connected to the electrical panel. Bonding connects all metallic parts of the electrical system to the grounding system, providing additional protection. The NEC provides comprehensive guidelines for electrical installations, including conductor sizes, overcurrent protection, grounding, and wiring methods. Adhering to these guidelines is crucial for ensuring safety and compliance. In addition, local building codes often incorporate or amend the NEC, so it is essential to verify and adhere to local regulations. Proper planning is essential for successful electrical installation in log homes. Start by creating a detailed layout of the electrical system, including the locations of receptacles, switches, lighting fixtures, and appliances. Consider the needs of the occupants and the functionality of each room when planning the electrical system. Determine the load requirements for each circuit and select the appropriate conductor sizes and overcurrent protection. Furthermore, select suitable wiring methods for log home construction. Non-metallic sheet cable is commonly used, but must be protected from physical damage. Conduit provides excellent protection and is often preferred in log homes. Always use weatherproof materials and fittings in areas exposed to moisture. Prior to installation, inspect the logs for any cracks, rot, or insect damage. Address any issues before proceeding with the electrical work. The electrical system must be properly grounded to ensure safety. Install a grounding electrode system consisting of a ground rod or water pipe connected to the electrical panel. Bond all metallic parts of the electrical system to the grounding system. Ground fault circuit interrupters provide enhanced protection against electric shock. Install GFCI protection in bathrooms, kitchens, and outdoor areas. Use tamper-resistant receptacles in areas where children are present. Consider surge protection to protect sensitive electronic equipment from power surges. Install a surge protective device at the service entrance. Ensure adequate lighting levels throughout the home. Use energy-efficient lighting fixtures and controls to reduce energy consumption. Plan for future expansion by installing extra circuits and conduit to accommodate future electrical needs. All electrical work must comply with the NEC and local building codes. Obtain the necessary permits and inspections to ensure compliance. Hire a qualified electrician who is experienced in log home construction to perform the electrical work. Log homes present unique challenges that require specialized knowledge and skills. Document the electrical system with wiring diagrams and panel schedules for future reference. Safety is paramount when working with electricity. Always de-energize circuits before working on them. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The common types of wiring typically used in residential homes, including log homes, are NM cable, also known as Romex, and MC cable. NM cable is a non-metallic sheath cable consisting of 2 or more insulated conductors enclosed in a non-metallic jacket. It is commonly used for interior wiring in dry locations. An C cable is a metal-clad cable consisting of two or more insulated conductors enclosed in a flexible metal jacket. It provides better protection than NM cable and is often used in areas where physical damage is a concern. Conduit is a raceway used to protect and route electrical wiring. It is typically made of metal or plastic. The different types of conduit include electrical metallic tubing, intermediate metal conduit, and rigid metal conduit. Each has its uses depending on the installation. Electrical boxes are used to house electrical connections and devices, such as receptacles and switches. They are typically made of metal or plastic. The different types of electrical boxes include outlet boxes, junction boxes, and device boxes. Each has its uses depending on what's being wired. The tools typically needed for electrical work include wire strippers, pliers, screwdrivers, a multimeter, a voltage tester, and a circuit finder. Wire strippers are used to remove insulation from electrical wires. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. A multimeter is used to measure voltage, current, and resistance. A voltage tester is used to verify that a circuit is de-energized. A circuit finder is used to locate circuits in an electrical panel. In a standard 120/240 volt single-phase, 3-wire system, the voltage between the two hot wires is 240 volts. The voltage between each hot wire and the neutral wire is 120 volts. The amperage rating of a circuit breaker is the maximum amount of current that the circuit breaker can safely carry. If the current exceeds the amperage rating, the circuit breaker will trip, interrupting the flow of electricity. The size of the wire required for a circuit depends on the amperage rating of the circuit breaker and the length of the wire run. The NEC provides tables that specify the minimum wire size for different amperage ratings and wire lengths. A GFCI is a device that protects against electric shock by monitoring the current flowing through a circuit. If the GFCI detects a leakage current, it will trip, interrupting the flow of electricity. GFCIs are required in bathrooms, kitchens, and outdoor areas. An arc fault circuit interrupter is a device that protects against electrical fires by monitoring the current flowing through a circuit. If the arc fault circuit interrupter detects an arc fault, it will trip, interrupting the flow of electricity. SIs are required in bedrooms and other areas where electrical fires are more likely to occur. Grounding is the process of connecting electrical equipment to the earth to provide a path for stray electrical currents to return to the source. Grounding is essential for safety and to prevent electric shock. Bonding is the process of connecting all metallic parts of the electrical system to the grounding system. Bonding provides additional protection against electric shock. The NEC is a set of standards for electrical installations. Compliance with the NEC is essential for safety and to ensure that the electrical system is properly installed. Local building codes often incorporate or amend the NEC, so it is essential to verify and adhere to local regulations. Permits and inspections are required for most electrical work. Permits ensure that the electrical work is performed by a qualified electrician and that the work complies with the NEC and local building codes. Inspections ensure that the electrical work has been performed correctly and that the electrical system is safe. When working with electricity, safety is paramount. Always de-energize circuits before working on them. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The NEC Table 310.15. The16 provides ampacity ratings for conductors based on their insulation type and ambient temperature. This table is crucial for selecting the correct wire size for a given circuit. For example, a 15 amp circuit typically requires 14 American wire gauge copper wire with 60 degrees Celsius insulation, while a 20 amp circuit typically requires 12 American wire gauge copper wire with 60 degrees Celsius insulation. NEC Article 250 covers grounding and bonding requirements. Proper grounding and bonding are essential for safety and to prevent electrical shock hazards. The grounding electrode system must be properly installed and connected to the electrical service. All metal components, such as conduit and electrical boxes, must be properly bonded to the grounding system. NEC Article 210.8 specifies the locations where ground fault circuit interrupter protection is required. GFCIs are required for all 125 volts, 15 amps and 20 amps receptacles in bathrooms, kitchens, garages, and outdoor areas. NEC Article 406.9 specifies the requirements for weather-resistant receptacles in damp or wet locations. Weather-resistant receptacles are designed to withstand exposure to moisture and are required in outdoor areas and other damp locations. NEC Article 314 covers outlet boxes, conduit bodies, and fittings. Outlet boxes and conduit bodies must be properly sized and installed. Ensure that the boxes are securely mounted to the logs and that all connections are made properly. Use weatherproof boxes and fittings in areas exposed to moisture. NEC Article 334 covers non-metallic sheath cable. Non-metallic sheath cable is commonly used for wiring in log homes, but it must be protected from physical damage. Avoid running non-metallic sheath cable in areas where it is likely to be damaged by settling or movement of the logs.